really no other state.
Okay, so we're on unit 12.4.
That's not a track.
Unit 12.4, and that is finding sums. Hey, hello. Of infinite. If we're finding the sum of something, is it going to be a series or a sequence?
Series.
Which are the ones that you find sums of, meaning adding things up? Series, right? If it has plus signs in between, if we're adding things up, it has to be a series. So finding the sums of infinite series, meaning infinite means they never end. Okay, so for example number 1, I would like you to find the sum of 4 plus 2 plus 1 plus half plus a fourth and an eighth and a 16th, and let's just keep going. Dot, dot, dot. It never ends. Never ends. So, does anyone, okay, first off, do you think this is a geometric or an arithmetic series? Okay, let's look at it. To get from 4 to 2, what would you add? What would you add? Negative 2. Can you add negative 2 to get from 2 to 1? No, therefore it has to be what? Geometric, because you're not adding something consistently. Okay, this has to be geometric. Okay? If it's geometric, then it has a what? Common what? Not difference, but a common ratio. Okay? So how do you find the common ratio? We have to think about how do you get from 4 to 2? What would you multiply by to get from 4 to 2? Remember, it's a little bit easier if we look at the fractions. So what would you multiply by to get from 1 to 1 in the top? 1. Over, what would you multiply by to get from 2 to 4? 2. So the common ratio is 1/2. Now, could you multiply by 4 times 1/2 to get to 2? Yes. Okay, so you can check them, but it's easiest to find the common ratio dealing with the fractions, actually. This is one of the few times that we actually kind of like fractions. So we know the common ratio is 1/2, so yes, it is a geometric series. We know it's a series because there's plus signs in between. So let's look at the pattern. Okay, if we are going to add these things together, okay, if we just add up one term, we would just be adding 4. And the sum, I'm going to make a little column here. The sum of just adding the first term would be what? 4. Okay. What if we add the first 2 terms? Then we would add 4 plus 2. 4 plus 2, your sum would be what? 6. We're just adding. This is not a trick question. What if I add the first 3 terms? Then I'd really be adding 4 plus 2 plus 1. What would that equal? 7. Okay, how about if I add the first 4 terms? That's really 4 plus 2 plus 1 plus 1/2. What's 4 plus 2 plus 1 plus 1/2? 7.5. So let's just say 7.5 because it's a little bit easier instead of writing mixed numbers. What if we got the first 5 terms? First 5 terms would be 4 plus 2 plus 1 plus 1/2 plus a fourth. What do you get if you add 4 plus 2 plus 1 plus 1/2 plus a fourth? It's basically 7.5 plus 1/4. 7.75. Think like dollars, okay? You know, like 7.5, so $7.50, $7.50 plus a quarter is $7.75, right? If we add the first 6 terms, okay, you're going to add all of those plus 1/8. Would you trust me in telling you that it's 7.875?
Yes.
Okay. If we add the first 7 terms, you're going to add all of those plus 1/16. That will equal 7.9375. Okay. Do you notice a pattern here?
Yeah.
What pattern do we, kind of, sort of, what do we notice? It's increasing. Yes, it's increasing, okay? So first it increased by 2, then 1, then a half. Do you notice that it's increasing very little,
Yes.
right? This is increasing very little, okay? And it is approaching, a number. We call this number called its limit. Okay, it's approaching a number. Approaching means getting really close. It's never actually going to get there. Okay? So it's approaching a number called its limit. Okay? In this case, what number is it approaching? 8. Okay, so we would say the limit of this series is 8. Now, it's kind of annoying if we have to take every single problem and add them all together and then see what is it kind of getting close to, okay? So there is a formula that I'm going to give you, okay? And this is a formula for an infinite meaning never ending, infinite geometric, and we determined it was geometric at the beginning because it had a common ratio, not a common difference. Infinite geometric decreasing is an important part here, series. Okay? How do you know if something is decreasing? What does decreasing mean? It's getting smaller. Does not mean going down. Okay? If it's getting smaller, I mean closer to 0, not more negative. Okay, so if something is getting more negative, it's not necessarily getting smaller. I want you to think smaller numbers, like smaller fractions. Okay, so infinite geometric decreasing series. And the formula for that is sum of infinity. Infinity is kind of like an 8 sideways, equals A1. What is A1? A1 stands for what? First term, divided by 1 minus R. 1 minus its common ratio. As long as your ratio is in between 1 and -1. So your ratio has to be between 1 and -1. If it's not between those, this will not work. Okay, and I'll show you some of those in a little bit. So as long as your ratio is a fraction, it can be a negative fraction, but as long as your ratio is a fraction, then it is an infinite, then you can use, the infinite decreasing geometric series formula. So, let's use the formula. Okay, so for number 1, if I was going to use this formula, okay, we said sum of an infinite series is equal to A1 over 1 minus R. Nope, I'm just going to show you how we could use this formula on number 1. So what is your first term? What's your A1? 4. Over 1 minus, what's your ratio? What did we figure out our ratio was? 1/2. So if we work this out, you're going to get 4 divided by, what's 1 minus 1/2? 1/2. This is basically saying 4 divided by 1/2. Would you agree that those are exactly the same? Yeah. It just looks nicer if it's not a double fraction like this. How do you divide by a fraction? What's this? How do you divide by a fraction? Dividing by a fraction is the same thing as multiplying by what? Multiplying by its reciprocal. So this is really the same as 4 times. Reciprocal of 1/2 is 2 over 1. You multiply those together, 8 is our answer. So if you use this formula correctly, you do not have to write out every single term and figure out what it's getting closer and closer to. That's why we want this formula, because otherwise this is a giant pain in the butt. We don't want to do that. So now that we know the formula, let's use it a couple times. Okay, let's use it. Example number 2. I would like you to find the sum of 270 plus 90 plus 30 plus 10 and keep going. Dot 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 means infinity. So just keeps going. I'm not going to tell you when to stop. So first thing you want to do here is check the ratio. Okay, check the ratio. What is the ratio? How would you multiply to get from 270 to 90? What would you multiply by to get from 270 to 90? Say it again? 1/3. Now, if you don't know how to do that, the way that you can find the ratio is you take any number and divide by the one before it. So you could take 90 divided by 270. Okay, you take any of the terms, divide by the one before it, and then reduce, which is 1/3. Okay, so that's your ratio. Does that work? Can I use my formula for this ratio?
Yeah.
Yes. Okay, remember, ratio has to be between 1 and -1 to use the formula. Okay, so check to see that the ratio is between 1 and -1, and this is. So now we can use our formula. So sum of an infinite series is equal to A1 over 1 minus R. So if you plug in, what's your A1? 270. Divided by 1 minus, what's my ratio? 1/3. So 270 divided by, what's 1 minus 1/3? 2/3. So if you rewrite this, this is 270 divided by 2/3. An easier way of doing that is what? Multiply by the reciprocal. So 270 times 3 over 2. Then you can cross cancel. So 270 and 2 cross cancel to give you 135. 135 times 3 gives us what? You can use calculators for this.
405.
405. That is your answer. Now, will it ever actually get to 405? No, but it's going to get 404.99999 and keep going. So we round to say 405. So the limit of this series is 405. If you ever get to calculus, you will do a lot with limits. Okay? I don't quite remember what for, but you will do a lot with limits. Let's try another one. For number 3. Okay, again, I want you to find the sum of 1 plus 10 plus 100 plus 1,000 and so on. Find the sum of 1 plus 10 plus 100 plus 1,000 and keep going. So, first thing you want to do, check your ratio. Okay, has to be between -1 and +1. What is the ratio? How do you get from 1 to 10? 10. Does that work in my formula? No. If you were going to keep adding these together, what would be the next term? 10,000, then 100,000. They're getting bigger. So do you think that you can give me a sum? No. Okay? The answer here is no sum. Do not write infinity. Infinity is not actually a number. It is a concept. Okay? Infinity is not actually a number. So the answer here is no sum. Do not write infinite. Okay? That is not the correct word. So no sum because you can't use the formula. Okay? Try another one. Number 4. Number 4, 80 minus 40 plus 20 minus 10 and so on. 80 minus 40 plus 20 minus 10 plus, keep going. Always, first thing you want to do, check your ratio. Do you think it's okay that these go minus plus minus plus? I don't know. First, you have to check your ratio. So if the ratio works, then you can use the formula. Then it works. So how do you find the ratio here? What would you multiply by to get from 80 to -40? Your ratio is -1/2. Okay? If you didn't just automatically see that, you can always take any number divided by the one in front of it. So you could take 20 divided by negative 40. And that would reduce to negative 1/2. Does that work? Is that in between 1 and negative 1? Yes. So that means you can use this. This is fine. Okay, so we're going to use our sum of an infinite series is equal to a1 over 1 minus r formula. What's your a1? 80 divided by 1 minus, what's your r? Negative 1/2. That negative does not count. Okay, so you have to write, this is a double negative. So if you have double negative, it turns into positive. So this becomes 80 divided by what? What's 1 plus 1/2? 1/2. We don't want to write mixed numbers, so how would you write that as an improper fraction? 3 over 2. Okay, so 80 divided by 3 over 2. How could I rewrite that? 80 times 2 over 3. Can you reduce 80 and 3? No. So you're going to multiply across the top. 80 times 2 gives you 160. Multiply across the bottom, 3. Can you reduce 160 over 3? No. Okay? It does not reduce evenly. I do not want decimal answers. Okay? So if you did 160 divided by 3 on your calculator, you're going to get me an answer. It's going to have a repeating decimal, so leave it like this. Okay? The sum is 160 over 3. And that is perfectly fine to leave it just like that.
How many examples?
8. We're going to switch and do something different in just a second. Okay? Number 5. Oh, you'll be fine. Okay, example number 5. This one, I want you to find the sum of, so that's a sigma. Sigma means sum of, between n equals 1 and infinity of 100 times 1/2 to the n minus 1. 100 times 1/2 to the n minus 1. Does this formula look at all familiar?
Kind of.
Should look kind of familiar. Okay? If you look at the formulas on the board, first off, we know this is what? For all of these problems, are these arithmetic or geometric?
Geometric.
Geometric. So we're only dealing with the geometric formulas. So if you look at just the geometric formulas, what does it look really similar to?
The geometric sequence.
The geometric sequence formula. Okay? This looks very, very, very similar to the geometric sequence formula. The geometric sequence formula is a sub n equals a1 times r to the n minus 1. Okay? Shortcut for doing this. Okay, actually, let me show you the long way first. Okay? If you don't see the shortcut, if you don't see what looks familiar here, that's fine. Then you'd plug in. Okay, so we're going to plug in. What's the first number you would plug into this formula? 1. Plug in 1, plug in 2, and plug in 3. So if you plug in 1 into this formula, you're going to get 100 times 1/2 to the 1 minus 1. So that's 100 times 1 minus 1 is 0. What's 1/2 to the 0 power? 1. 100 times 1 gives you 100. If you plug in 2, that would be 100 times 1/2 to the 2 minus 1, which is basically just 100 times 1/2, which gives us what? 50. Now, the only reason you have to plug in 3 is because I want to make sure that you know how to get the ratio. Okay, so you're going to check your ratio. Technically, we have our A1, we have our first term. You could find the ratio between just the first 2 terms, but I'd like you to plug in 1 more just to make sure. So this is 100 times 1/2 to the 3 minus 1. 100 times 3 minus 1 is 2. What's 1/2 squared? 1/4. And what is 100 times 1/4? 25. So from here, you know this is your A1. How do you find the ratio? What would you do to get from 100 to 50? What would you multiply by? Your ratio would be 1/2. So you have the A1 and you have the 1/2. Does your ratio work for my formula? Yes. So you could do sum of an infinite series is equal to a1 over 1 minus r. If you plug that in, what's the a1? 100. Divided by 1 minus, what's the ratio? 1/2. So 100 divided by 1 minus 1/2 is a half. 100 divided by 1/2, how can I rewrite that to be a little bit easier?
100 times 2.
Times 2 over 1, and if you multiply that together, what do we get? 200. That's your answer. Now, if you see something, do you see in this formula a shortcut? If you do, that's great and you can use it. If you don't, tune out for a minute. Does anyone see? What do you see? The A1 is where? First. What is A1? 100. The ratio is whatever's in the parentheses. What is the ratio that we figured out? 1/2.
Oh, so it's just.
So do you have to do first,
No.
second, third terms?
No.
No, you can just read it straight from the formula. 100 is your A1. This is your R to the n minus 1. Your R is 1/2.
Is it gonna be like that for everything?
Yes.
So then
Because most people don't see this. They don't see it automatically what's the A1 and what's the R in there. If you see it, that's fine. If you do not see it straight from the formula that you're given, you can plug in, find your A1, find your ratio. I don't care which way. Okay, if that confused you, then just ignore that for the last couple of minutes. Okay, so answer is 200, excuse me. Okay, now, next thing I want you to do. This is going to seem really simple. It's not very related to what we've been doing. But I want you to, we're going to work on writing fractions as decimals. Or excuse me, writing decimals as fractions. This is something that you should have learned how to do a very, very, very long time ago. Write 0.12 as a fraction. So going backwards from decimals to fractions. How do you write 0.12 as a fraction? This is 12 over what? 100. Reduce that. What does that reduce to? 6 over 50. And can you reduce that again? 3 over 25. That's your answer. You're going to see why we're doing this in just a second. So do we understand that, do we agree 0.12 is equivalent to 3 over 25, right? Now, next one I want you to do is I want you to write, we're going to learn how to write a repeating decimal as a fraction. Write this repeating decimal as a fraction. Most of you probably already know the answer to this, but you don't know why. What is 0.33333 repeating as a fraction? Is it
0.0009.
is it 3 over 10?
No.
No.
Is it 33 over 100?
No.
Is it 333 over 1,000?
No.
No. Okay? We know that it's 1/3, but why? Prove it to me. Can anyone prove that?
That's not what
That's me.
Oh, it is.
That's the hard part, okay? The 3's never stop.
Because
So I'm going to show you how to prove to me, I'm going to show you how to prove to me that this is 1/3. Okay, most of you know it's 1/3 because if you've ever done 1 divided by 3 on a calculator, you've seen this written before. Okay? But I want you to prove to me why. And you're not actually going to be showing me, right, 333 as a fraction on a test. But you are going to have other ones. I'm going to show you how to prove why. Okay? There's a trick that we're going to use. Okay? The trick is take whatever your decimal is and make it equal to x. So x equals 0.333 repeating. Okay? Then you're going to multiply it by 10. Okay, so you multiply by 1 and however many zeros there are repeating numbers. So multiply by 10. If I multiplied by 10, I would get 10x equals what? If I multiply this by 10, what does it equal? Multiply something by 10, what do? Just move the decimal place over 1. So 3.33, you still have that repeat. Do we agree? Just multiply by 10. Now, rewrite this underneath. and I want you to subtract it. So rewrite this as x equals 0.33, and we're repeating, right? Just line it up. And I want you to subtract. Okay, we're going to make basically a systems of equations here. When you subtract, what's 10x minus x? 9x. What happens here if I subtract? The decimals go away, right? This would equal 3.00, right? These cancel each other out. Do you agree?
Yeah.
Then solve. How do you solve for x? How do you get x by itself? Divide away the 9 and reduce. 3 over 9 reduced is what? 1/3. That's how you actually prove that. Okay, now, you're not going to have to prove it. But what you are going to have to do is convert repeating decimals, okay? I know that you know 0.333. If I gave you that on a test, you'd write 1/3. And you wouldn't show me any of the work, and that's fine. But I am going to ask you to write repeating decimals as a fraction, okay? So write 0.1515 repeating as a fraction. That's one that you don't probably know in your head. If you do, then good for you. But most people don't just know 0.1515 repeating as a fraction. Notice the 1 and the 5 are repeating. So we're going to follow the exact same steps. Okay? What do you think you're going to multiply by here?
10.
Not 10. We're going to multiply by 1 and however many zeros there are repeating numbers. So how many repeating numbers are there? 2. So that means 2 zeros. So really multiply by 100. Okay? The other one we only multiplied by 10 because there was only one repeating number. So it's a 1 and then however many zeros you have repeating numbers. So multiply by 100. If you multiply by 100, we already said that x was equal to 0.1515 repeating. If you multiply by that by 100, we're going to get 100x equals what? Move it over twice. So 15.15 repeating. Then line up whatever your x was equal to. Subtract, so change these, this turns into a systems of equations. Subtract. 100x minus x is what? 99x equals, what happens here with the repeating decimals? They go away. So it equals what? 15. Technically, if you want to write the 0.00, but you don't have to. How do we get x by itself? Divide away the 99. And then reduce. So x equals, how can you reduce 15 over 99?
5 over 11.
Divide by 3, 5 over 33. That's your answer.
I was
Okay?
22 off.
So you will have to do this on your test. Are there questions? Okay, homework for this objective is going to be page 823. You are doing numbers 7 through 19 odd, and I will put these up here for you to see so you can work on them. 7 through 19 odd, 20 through 26 all, and then 37 and 41. I know it's kind of jumping around a little bit, but these ones are kind of important because there's going to be ones just like this on your test. Okay, page 823, numbers 7 through 19 odd, 20 through 26 all, 37 and 41. Okay, like I said, I will put these up here for you guys to see so you can work on them.